Given question here, x is an exterior angle of the given triangle and the given triangle is an isosceles triangle. Therefore, the base angles are equal. Let's name the base angle as y. So we get y plus 42 is equal to 180 degrees. As we know, sum of the interior angles of a triangle is 180 degrees. Let's solve this equation for y. So 2y plus 42 is equal to 180 degrees. So 2y is equal to 180 minus 42 and 2y is 138 and y is half of 138, which is 69 degrees. So y is equal to 69 degrees. As we know, the exterior angle of a triangle is equal to sum of the opposite interior angles. Therefore, x will be equal to 42 plus 69, which is 111. Therefore, x is equal to 111 degrees. Let's see the B part of the first question. Here given that A is to B is to C is 3 is to 4 is to 5. As we know, the complete angle is equal to 360 degrees. So we can write it as 3x plus 4x plus 5x is equal to 360 degrees. So 3x plus 4x plus 5x is nothing but 12x, which is equal to 360 degrees. So x is equal to 360 divided by 12, which is nothing but 30. So the question is for find the value of c, as c is nothing but 5 times of the x. So 5 into 30 is equal to 150 degrees. So the value of c is 150 degrees. Let's see the C part of the question. Here let me draw a rough figure of pentagon and a hexagon. I hope this figure is fair enough. So here it is given that D is a exterior angle of the regular pentagon. So I will extend this side and name this angle as D, and I will name one of the angle of the hexagon as H. H is the interior angle of this regular hexagon and D is the exterior angle of this regular pentagon. As we know, the sum of the exterior angles is equal to 360 degrees. Therefore, each exterior angle is 360 degrees by n. Exterior angle. Here, the polygon is a pentagon. So, n is equal to 5. Therefore, exterior angle is 360 by 5, which is nothing but 72 degrees. So in case of hexagon, let me extend one of the side to form an exterior angle. Let me call it as x. We apply the same formula to find the value of x. So here in this case of hexagon, the exterior angle is 360 by 6, as n is equal to 6 because this is a hexagon. Therefore, here x is equal to 60. So we know that x plus h form a straight line. Therefore, angle x plus angle h will be 180 degrees. Therefore, h is equal to 180 minus x, which is 180 minus 60, that is equal to 120 degrees. So now we got D as 72 degrees, H as 120. So but that was not our question. They are asking to find the fraction of D by H. So let me substitute the values of D and H. D is 72, H is 120. But the answer is we have to present it as a simplest form. So as we simplify, let me divide this by 12. So I get it as 6 by 10. Still I could find it can be made as a simplest form. So still I divide this with 2. So final answer I get it as 3 by 5. So the value of the fraction d by h is nothing but 3 by 5. Let's solve the d part of the first question. So we have to prove that the given quadrilateral is a cyclic quadrilateral. For this, first we will find the value of x. As we know that sum of the interior angles of a quadrilateral is 360 degrees, we can form an equation with the given angles. X plus 2x minus 5 plus 3x minus 40 plus x plus 20 is equal to 360. By combining the like terms of this equation, we get 7x minus 25 is equal to 360. So let me move this 25 to the other side. That becomes plus 25. 7x is equal to 385 and x will be 385 divided by 7. X is nothing but 55 degrees. So let's find each angle. Angle S, which is nothing but x, which is 55 degrees. Angle P is nothing but 2x minus 5. Let me substitute x here as 55. So 2 into 55 minus 5, that is equal to 105 degrees. Angle Q is equal to 3x minus 40. So 3 into 55 minus 40, on simplifying it, I get 165 minus 40, which is 125 degrees. And angle R is x plus 20, which is 55 plus 20, 75. Okay. In case of a cyclic quadrilateral, opposite angles sum up to 180 degrees. Let's check this condition to this given quadrilateral. The opposite angles are S and Q. So S plus angle Q is equal to 55 plus 125. Yeah, we got it as 180 degrees. The other two opposite angles are angle Q plus angle P, which is 75 plus 105, which is again 180 degrees. Therefore, we can say that the given quadrilateral is a cyclic quadrilateral. Solve the E part of the first question. In the given circle, the radius is 9 cm and minor sector angle is 50 degrees. As we are asked to find the length of the major arc, for this we need major sector angle. Let me mark it as x. So let me mark this as x. So therefore x is equal to 360 minus 50. So we get the major sector arc as 310 degrees. As we know, the length of an arc is x by 360 into 2 pi r, and we know x is 310 degrees and r is equal to 9 centimeter, and pi value we take it as 3.142. Let's substitute these values in this formula. So therefore the length of the major arc is equal to 310 by 360 into 2 into 3.142 into 9, which is nothing but 48.701. Approximately we can write it as 48.7 or 48.70.